All right, this is going to be the video for note 63. Depending on length, I might pop it up into multiple videos. We'll see. I intend to make one, but again, it will depend on how long this takes. All right, so we have word problems, and they're going to turn into quadratic equations. So what we've got here is a rectangle that has a length that is 4 meters more than the width. So immediately, I'm a visual person. I want to draw this. All right, so how wide is this? I have no idea. I'm going to call it X. You could call it W for width if you wanted to. You could put a smiley face down if it made you happy, okay? Now, how long is it? The answer is I don't know that either, but I don't want to set up a two-variable equation and say, oh, this is Y. That's too much. I'm told in this problem, I've told you that the length is 4 meters more than the width. So if the width is X, 4 meters more than that is going to be X plus 4. Okay? Now, the secondary part to this problem, which is where the equation is going to come from, is I'm telling you the area of the rectangle is 117 square meters. Well, you might be asking yourself, how does that help? Well, to find the area of a rectangle, you take the width times the length. So if I take the width of X times the length of X plus, whoa, hold on a second, X plus 4, that is equal to 117 square meters. That's what I'm going to need to solve. Okay, so let's go ahead and do a little distributive property here and here. So it's going to be X squared plus 4X, and then it's going to equal 117. To solve a quadratic, I want to get this equal to 0. So I'm going to subtract 117 from both, 117 from both sides. So this is going to equal 0. The left side, I'm going to end up with three terms. So X squared plus 4X minus, did not give myself enough space. I should know better. So there's 117. Now, I am going to attempt to factor this. 117 is not the easiest number in the world to work with. I am going to pop up a calculator here because, yeah, I'm going to clear out the mess that I had in there. I've got a feeling 117 is divisible by 3. Okay, cool. Which also means that 117 is divisible by, there's the 9. So 9 and 13. Wow, I'm good at this game. All right, so I'm going to split the X. 117 is 9 times 13. I'm going to double check that. So 9 times 13 is 117. If I take 13 minus 9, I get the 4 in the middle that I was looking for. So there's going to be positive 13 and a negative 9. Okay, and if you want to double check my math, feel free. 13 times negative 9 is negative 117. 13 minus 9 is the positive 4 right there. Take your factors, set them equal to 0. You get X equals negative 13. X minus 9 equals 0, which means X is equal to 9. Now I'm going to make the calculator move here. Maybe. There it goes. Okay. What I'm asking for is the dimensions of the rectangle. So I want to know what is the length times the width. Now, what I mean by that is dimensions are things, you bought pictures before maybe, or you've ordered pictures or seen pictures, and 8 by 10 are the dimensions. So when I look at this and I say, oh, X is equal to negative 13, I don't know about you, but I've never heard of any rectangle that has a width or a length that is negative. Because this is an example of a real world kind of application, is modeling a real world situation, this negative 13 does not make any sense. Okay, so what you have here is a width of 9, and this is 9 meters because everything in the problem was in meters, and then the length is the X value, which is 9 plus 4. 9 plus 4 is 13 meters. So 9 by 13. The little X in the middle here is read as 9 by 13, or you could literally write 9 meters by 13 meters. I don't care if you write it out or use a little X. That's whichever one makes you happy. All right, so that's problem number one. I probably should have put a little asterisk there for a calculator. I did not, my apologies. Number two, I absolutely did put an asterisk, mostly because as soon as I saw this area of 100 and 420, I was like, probably a calculator problem. Okay, so let's see. We have a rectangular garden, okay, where the length was 2 meters less than twice the width. Ooh, okay, let's break this apart. So here's my rectangle. How wide is it? Don't know, going to call it W. You can, again, W, X, Y, Q. Pick your variable of choice, okay? Now it says the length is 2 meters less. So we're going to have to subtract a 2. That's the less part, right? Subtracting 2. Then twice the width. Well, twice the width is going to be 2 times W, and then 2 meters less than that would be minus 2, okay? The area of the garden was 420. So area, again, we're going to take the width times the length. So width is W times 2W minus 2 equals 420. So a little distributive property, 2W squared minus 2W equals 420. I'm going to go ahead and move the 420 to the other side, so I'm going to subtract 420. Put the 4 first. All right. So I'm having trouble writing W's. W squared minus 2W minus 420 equals 0. All right. Now, every single term here, including the 0, is divisible by 2. So I'm actually going to divide everything by 2. It's going to make the number smaller. All right, so W squared minus W minus 210 equals 0. I'm going to double check the 420. 420 divided by 2 is 210. Okay, I can math today. And then let me get rid of that. There we go. So let's see what kind of factoring I can do here, what kind of magic we can get. I'm looking for two things that multiply to negative 210 and add up to negative 0. So I already know the W is going to split easily, right? W and W make the W squared. 210 divided by 37. No, that ain't it. 210 divided by 15. Hey, 15 and 14. So here's the thing. It's kind of a guess and check, right? If you want to start listing off the things that multiply up to 210 off to the side, absolutely do it. I just kind of play around with the calculator a little bit, and I got the 15 times 14. So as a double check, 15 times 14 makes my 210. To make the negative W, I need the 15 to be negative and the 14 to be positive. All right, and of course I write too large. Shocking, I know, but off to the side here, I'm going to go ahead and take each factor and separately set them equal to 0. So W minus 15 equals 0, W plus 14 equals 0. So that's going to get me W equals 15 and W equals negative 14. Does not make any sense in the universe to talk about a rectangle with a negative length. Gonna go ahead and eliminate that immediately. I am asking for the dimensions of the garden again. So I know its width. Its width is 15. All the units here, I think, were in meters. So this is going to be 15 meters by. Now, the length here is 2 times W minus 2. So I'm going to take 2 times my 15 and then minus 2. So let's go ahead and do that here. So 2 times 15 minus 2, it's going to be 30 minus 2. So it's going to be 28 meters. Give myself space. And then if you want to double check this, right, I've told you the area of the garden was 420. So if I take 15 times 28, so 15 times 28, oh, look, there's that area that we had originally of the 420. All right, so that does, in fact, give me the right dimensions there. All right, last but not least, problem number 3 here. I'm going to go ahead and just keep on going. This will be the last problem of the video. It's the last problem in the notes. The square, oh gosh, okay, the square of a number. So a number, the x squared, okay, the square of a number, increased by twice the number, so 2x, is 48. All right, so I just took this apart in pieces, okay, and I'm going to actually kind of slide this down. All right, so you can kind of go in here, and I'm going to take apart the pieces again. All right, the square of a number. So this is where I came up with the x squared, okay? Then I have increased by, so that's going to be the addition. Then I've got twice the number. So the number that I used here, which I didn't know what it was, so that's why I picked x, is going to be the same number here. This time I want to do twice that number. So let's go ahead and call that 2x, okay? And then is, there's my equal sign, so is, and then obviously it just says 48 there, so equals, let's see, 48. All right, that created my equation. Now I want to solve this equation. And this is basically whatever I get is what I get. So let's go ahead and solve this mess. So to make it equal to 0, subtract 48 on both sides. So x squared plus 2x minus 48 is equal to 0. I do not actually need a calculator for this one. I know that 6 times 8 is 48. And if I make my 8 positive, my 6 negative, that would make the negative 48, and it would also make the positive 2. So I'm going to set each factor equal to 0. And then I get x is equal to 6 and x is equal to negative 8. Now, here's the thing. Specifically, I'm telling you find the solutions, plural. This also does not specify a particular real-world physical object. So it just says a number, and numbers can be negative. So we've got x is equal to 6 and x is equal to negative 8. Both of those are solutions to problem number 3. All right, hopefully that video wasn't too long, but it did get us through all of Note 63. As always, let me know if you have any questions or concerns, and I will see you in the next one.